Hi, warm welcome on Yaman's MATLAB coding. In this clip, we would like to discuss how one can determine the stability of a control system from pole zero map. Viewer needs the background of clip 48, where we discussed how one can graph the S-plane plot or pole zero map for a given control system in MATLAB. We know that any control system is characterized by a transfer function. Transfer function can take many forms, one of which is coefficient form, the other is pole zero gain form, and the third one can be state space form. Whatever be the transfer function form, the control system is unstable if any pole of the transfer function is located on the right half plane. And how do we check that? The check can happen by two ways. The first one is visual inspection from the graph, and the second one is by programming or algorithmic means. On the screen, you see the example 2 of clip 48, whose pole zero map is shown on the next slide. We have encircled the poles which are on the right half plane. So as you see, there are four poles on the right half plane. So the control system represented by this transfer function must be unstable. We just addressed how one can determine the stability of a control system by visual inspection. Now we would like to address how one can determine the stability by using programming means. But for that, viewer needs the background of clip 19, where we addressed output and input arguments of a function file, because here we have to provide some output arguments. In the PG map for ongoing process, we did not use any output arguments. This time around for programming means we would like to add two output arguments. The first of which poles and the second of which zeros. And the viewer needs to provide two variables. Here we provided P and Z. You can choose any variable you like. So go to MATLAB command prompt, write P and Z as output argument, and then call PG map over the transfer function G. After execution, in the next command line, your poles and zeros will be available. We just call the poles because the stability only related with poles. After calling the P, we find there are 7 poles. Some poles have positive, some poles have negative real parts. Positive real part indicates the system is unstable. How to program the decision making of stability using code? We have poles in P. If we use command real over P, we're going to have real part of the poles. Now, if we compare every real part with 0, whether it is greater than 0 or not, then we can get true or false. I mean, whether it is greater than 0 or less than 0. Greater than 0 means on the right half plane, less than 0 means on the left half plane. Now, there is a function by name any. Any input can be true or false. If the comparison result is true, the return will be 1. If the comparison result is false, the return will be false. And 1 for true, 0 for false. So go to MATLAB command prompt, execute any of real of p greater than 0, and you're gonna see the result as 1. That means there are some poles which has real part greater than 0. That means on the right half plane, or in other words, the system is unstable. If the return were 0, we would say the system is stable. And that's it. Thanks for sticking around. Do share, like, and subscribe our contents. I hope to see you in next clip. Bye for today.